UNCLOS stands for United Nations Convention on the Law of the Sea, which is an international law that was ratified and became international law in 1994, and that describes and regulates the activities in the oceans. One of the articles of UNCLOS is Article 76, which is an article that gives you the guidelines for defining an outer limit of a continental shelf beyond 200 nautical miles, provided that the geology of the continental shelf allows you to do so. Canada is one of the countries in the world that has a continental shelf with the geological aspects of defining it beyond 200 nautical miles, and therefore we launched the project in 2004. The importance for Canada is that in that extended area beyond 200 miles that Canada can define as its extended continental shelf, Canada has the sole jurisdiction on the exploration and exploitation of natural resources. So that means the resources on and below the seafloor. The decision we made at the beginning of the project is we use as much as possible standard technology. Now, if you take standard technology and go to the Arctic, you have to modify it. So we had to modify some of the things, but it still was standard technology of acquiring scientific data. However, the ice conditions were so unpredictable in the Arctic that we, halfway through the project, decided that rather than breaking ice with icebreakers, because in some places that was rather difficult, having an ice camp that became rather dangerous because the ice started breaking up under and near the ice camp, we decided to go with another project and go under the ice. We acquired 2 autonomous underwater vehicles. Those are torpedo-shaped vehicles, about 7 meters long. Autonomous means you basically program it to go to certain points and come back. They had never been used under those kind of circumstances in the Arctic. It was even a lot more complicated because when they had to go back home to the location in the ice is not stationary, ice moves. So their home during those 3 days might have been moved 10-20 kilometers. So it had to find a hole about the size of a table in a location that was not where it was supposed to be. The first time that we did this, there were 5 or 6 journalists waiting over my shoulder saying, "Are they there yet?" kind of thing. The historical first is certainly the autonomous underwater vehicles and the distance they traveled under the ice. That has never been done before. If you work in the Arctic, interesting and challenging moments are always the logistics, because you have to plan so many 12 to 16 months ahead. Before we started this project, there was 3,000 kilometers of seismic data. We added 15,000 kilometers from this project. So it's not a small addition to the knowledge, it's a quantum jump. And of course, when you add more data, you get more information, you get more knowledge, you get more opportunities to test your ideas. It's not that we now have solved the entire Arctic. We now know a lot more than before, but there still are a lot of questions, because once you answer a question, it immediately brings to the forefront the next question. Yeah, that's always the case. So we never stop.